Alright, good morning, ladies and gentlemen. This is OJB. I'm going to read you few paragraphs about what's called the PhOENIX theory. It's a very interesting one concerning entangled particles, entangled energy. Alright, so here goes. PhOENIX. The physics of entanglement networks and information exchanges is based on topology and combinatorics, whereby all the known particles in physics can be represented as information which has been spatially entangled into networks of vertices. According to E equals mc squared, mass is nothing more than entangled energy. With PhOENIX, we have decoded how that energy becomes entangled, how it forms particles, and how those particles interact according to simple rules using graph theory. A graph with n vertices is represented by an n times n matrix called a coordinate matrix. Here's a video here, so I'm going to read this paragraph here below the video. PhOENIX is a new combinatorics language of physics. As Bohr, the father of quantum mechanics, recognized there must exist a correspondence between the old language and the new. This Rosetta Stone exists for PhOENIX. With respect to particle graphs, we call it the quark methodology, and it enables us to identify a graph with a particle. Recall that quarks are strongly bound to each other, such that only certain configurations appear as free particles. That is, they cannot exist on their own. We'll discuss the meaning of quark-gluon plasmas at another time. In PhOENIX, this quark confinement is necessitated by the requirement that all vertices be connected with edges and/or tadpoles, loops, and arrows. A particle graph cannot have unfixed edges. It cannot be a tree. In this way, the entirely combinatoric structure fully maps the gluonic structure of quarks. As such, we can identify the structure of charged quarks via the structural correspondence. Because the electron is a real independent particle graph with 3 loops, t equals 3, it establishes a benchmark for the correspondence between the number of tadpoles and the electric charge. From this, the quarks' vertices must be interpreted as having fractional electric charges, but because they cannot exist in and of themselves, the association is merely a method for mapping. Additionally, the assignment of a value to the concept of charge is purely arbitrary, but once assigned, it fixes the values for all systems. This initial arbitrariness is the reason for why the bare electric charge of a particle, like the electron, must be inserted into our current standard model of particle physics. The arbitrariness of electric charge is made as an assumption. The PhOENIX provides an entirely non-arbitrary meaning to electrical charge. It is simply a mapping function based on the total number of tadpoles, t equals loops minus arrows, or the trace of the matrix. Of any completely independent graph or system of graphs, we also prove that this new number of tadpoles property is invariant, conserved in all particle reactions. Here's the mapping function. T for Q equals O, T equals O for Q minus O, Q equals O, T equals the plus or minus 1 for Q equals plus or minus 1, T equals plus or minus 3 for Q equals plus or minus 1, T equals plus or minus 4 for Q equals 0, T equals plus or minus 5 for Q equals plus or minus 1. Because some of this is proprietary, we cannot yet fill all the gaps for you until we are ready. We will release them in the second paper on quantum scattering in physics. This is our Rosetta Stone correspondence, our quark methodology between the original charge concept and the new tadpoles on vertices combinatorics concept. Basically, the concept of charge in PhOENIX is expressed through combinatoric principles. In order to connect with the language, with the language structure of the standard model, which other physicists are going to be more familiar with, we have to use a mapping or Rosetta Stone to connect our new methodology. Methodology with the old methodology in a way that follows the principle of correspondence. Here you can see a graph. A map here says the map shows us the visual knots of structures of PhOENIX and how they relate to the fundamental particles in physics, such as quarks, leptons, hadrons, baryons, photons, and so forth, etc., as closed-loop knots. Photons are minimally interpreted as a connected point of information change between two vertices. The simplest leptons are single vertex particles, while mesons and baryons are bundles of two or more entangled vertices. And it says here, I'm going to read one paragraph. Antimatter looks similar to matter, except the loops are replaced with arrows. And this is what leads us to the topological conclusion that antimatter is the key to quantum disentanglement. This, it says here, because it will isolate and choose all the particle loops inside of a bubble surrounded by the special type of quantum topological landscape of antimatter, also called Dirac holes. Oh, that's nice. All right, I like it. You can see here, it says, it just explained it here. If there's an antiparticle connection there, it's going to show them as arrows, as we can see here. And if they have, as a positron is, positrons are negative electrons, or anti-electrons rather. We can see the electron has its loops there, as opposed to the positron with arrows. Yeah. So it's a really nice way of seeing the different combinations of these quarks and the subatomic nature of these quarks, their structures and so forth. Interesting. Well, folks, hope you enjoyed this. Hopefully this hasn't been too long. We're at 7 minutes and 45 seconds. Thank you very much. Cheerio.